This is an introduction to Laplace transform, and in Laplace transform we have this basic formula. We have the Laplace transform of f of t is equivalent to the integral of e raised to negative st times f of t, your function here, and then dt with our limits from 0 to infinity. This formula is named in honor of the French mathematician and astronomer Pierre Simon Marquis de Laplace. So we use this one to solve some engineering problems, especially in the fields of ECE, in particular to mixed signal processing. Okay, so when we write the Laplace transform of our function, let's say the Laplace transform of f of t, we have here the Laplace transform of f of t that is equivalent to f of s. By the way, when we write our Laplace transform, we make use of this capital letter L. And then we have to use this letter L. And also, it is enclosed, our function is enclosed by a bracket. Okay, so the Laplace transform of f of t is equivalent to f of s. And if we have the Laplace transform of g of t, so we have here our bracket, the Laplace transform of g of t, so that is equivalent to capital letter G and then S, G of S. Okay, so that's it. G of S. Also, when we write our Laplace transform of y of t, so we have our bracket that is equivalent to capital letter Y and then y of S. Okay, so this is how we write our Laplace transform of any function. So when we apply this formula, for example, let's say example 1. Example 1. We're going to find the Laplace transform of, let's say, 1. So any number, no? So if we take the Laplace transform of 1, of course we will make use of this formula you have here that is equivalent to the integral with limits from 0 to infinity of e raised to negative st times our function, which is 1 dt. Of course, 1 dt is dt. So that the integral of e negative st, that is equivalent to negative, let u equals negative st, du equals negative s dt. So we have here negative 1 over s, okay, e raised to negative st. That is our integral of this function. And of course, our limits is from 0 to infinity. So this will be our limits. And then, if we substitute our limits, so we have here negative 1 over s times e negative s times t, which is infinity. Okay. Upper limits, that will be our upper limits, minus the lower limits, that is e raised to negative s times 0. Okay, this one, 0 times negative s equals 0. And then e raised to 0, that is equivalent to 1. So this one is equivalent to 1. And then this one, e raised to negative s times infinity, this is equivalent to 0. When you have here infinity, so this is equivalent to 0. Therefore, 0 minus 1, negative 1 times negative 1 over s, that is equivalent to 1 over s. So this is now our Laplace transform of 1. That is 1 over s. Okay. And the next example, we have here example number 2. Example number 2, or we will write directly number 2 as our example. Okay. So we have here number 2. Let's say we want to find the Laplace transform of t. When we find the Laplace transform of t, that is equivalent to our integral sign with limits from 0 to infinity, e negative st, times of course our function which is t, dt. So if you have noticed this one, this is integration by parts. So if this is by parts, we will have here, we will be using the shortcut method of by parts. We have here our u as t, and then our dv equals e negative st. This will serve as our u, and then this will serve as our dv. Okay, in u, we take the derivative of t, that is 1, and then derivative of 1, that is 0. This one, if we integrate, that is e raised to negative st integral, that is let u negative st du equals negative s. So negative 1 over s e negative st. And then if we integrate this one, negative s times negative 1 over s times negative 1 over s, that is 1 over s squared e negative st. So we will just multiply this one directly. This is positive, this one is negative, so that our solution here, when we integrate our function, that is t negative st, so negative t over s, this one negative t over s e, this is s, e negative st, and then this is negative instead of plus, minus, we will be using minus 1 over s squared, and then e raised to negative st. Okay, this time we will make use of our limits from 0 to infinity. So that is equivalent to our infinity t. You have here upper limits, that is negative infinity. Instead of writing t, we will use infinity over s, e negative s times the infinity minus 1 over s squared e negative s times the infinity. This is upper limits minus the lower limits, that is 0. So we have 0. This t is 0 times this one, that is of course 0, minus this one 1 over s squared e raised to s times 0 equals 0. So this is e raised to 0. This one, e raised to 0, is equal to 1 times s squared. Take note of this one. Okay, so I will just change the color of my pen. So let's say red. This one, of course, this is equivalent to 0. This is also equivalent to 0. You have your infinity raised to infinity. Infinity times this one, that is 0. And then what remains here is of course negative times negative, that becomes positive. Okay, negative times negative, that becomes positive. So that is equivalent to 1 over s squared. Okay, so 1 over s squared. This is our Laplace transform of t. Take note that the Laplace transform of 1 equals 1 over s, and then the Laplace transform of t equals 1 over s squared. This is the case when we make use of this formula. Now, in the solution, or in computation of Laplace transform, we make use of the table. So take note again, the Laplace transform of 1 equals 1 over s. This time, if we look at the table of Laplace transform, we have here the table of Laplace transform. Okay, this is our function. And then its Laplace transform is f of s. So we have here the table of Laplace transform. If our function is 1 or any number, then its Laplace transform is the number divided by s. So if this is 1, so its Laplace transform is 1 over s. If our function is 2, then its Laplace transform equals 2 over s. Okay? Now, if we have e raised to at as our function, then its Laplace transform is 1 over s minus 1. So we can make use of this table in order to find the Laplace transform of any function. So notice in our example, we have here the Laplace transform equals of 1 equals 1 over s. If you look at the table, we have the Laplace transform of 1, this is our f of t, that is equivalent to 1 over s. Another one, in our example, the Laplace transform of t, that is 1 over s squared. So if you look at our table, the Laplace transform of t, we have this one over s squared. Take note, our t is raised to 1. So that is t raised to 1. So this case, this is n. So n factorial, that is 1 factorial equals 1. And then 1 plus 1 equals 2. That is why we have 1 over s squared when we solve our example 2. 1 over s squared. So we can make use of our Laplace transform table. Now, we will have another example. This time, we will be using our Laplace transform table. So, let's say example number 3. Find the Laplace transform of, okay, I will rewrite this one. Okay, find the Laplace transform of, let's say, e negative 3t. Now, to solve this problem, e raised to negative 3t. Okay? Take note, e raised to negative 3t. So, if you look at the Laplace transform table, we have here e, this is our function e raised to at, which is equivalent to its Laplace transform equals 1 over s minus 1. Okay, take note, e raised to at equals 1 over s minus 1. E raised to at equals 1 over 1 s minus 1. So again, we have here s minus a, s minus a, 1 over s minus a. So this is now s minus a. So if you look at this one, this is e raised to negative 3t. So its solution now is 1 over s minus our a for this case is negative 3. So minus negative 3. So that is equivalent to 1 over s plus 3. Negative times negative, that is positive 3. So when we solve Laplace transform using this function, and then we will make use of our table, so we can find directly our answer for its Laplace transform. Another example. Okay, so we will now erase this one. Another example, let's say example number 4. We're going to find the Laplace transform of sine to t. Okay, so the Laplace transform of sine to t, we have to look at our table of Laplace transform, that is sine to t. So if we look at our Laplace transform, that is sine 2t. Okay, sine 2t. So we will make use of this formula. Our function is sine at. Okay, sine at equals a over uh, s squared plus a squared. So that is sine 2t. Okay, a squared minus uh, a squared. I mean s squared minus a squared. So this is sine at, a over s squared plus s squared plus a squared. So we have to go back to our example, sine 2t. So again, sine 2t, I have to repeat this one. That is a over s squared plus a squared. So a over s squared plus a squared. So we have our a here is 2. So we have here 2 over s squared plus a squared, that is 2 times 2, that is equivalent to 4. So basically this will be our final answer. Okay. So another example, let's say number 5. Example number 5, we have the Laplace transform of 1 plus 5t. And then we have to close this one. So if we take the Laplace transform of this function 1 plus 5t, okay, so allow me first to transfer this one. Okay. So we have the Laplace transform of 1. We have the Laplace transform of 1 plus the Laplace transform of 5t. If we have here Laplace transform of 5t, we usually write this part as 5 times the Laplace transform of t. If you have a number before your variable, then we will write first 5 times the Laplace transform of t. Therefore, for this case, the Laplace transform of 1, we know that the Laplace transform of 1 equals 1 over s. 1 over s plus, of course, the Laplace transform of t, we have here 1 over s squared. 1 over s squared, that is the Laplace transform of t, multiplied by 5, that is 5 over s squared. Or if we combine these two variables, we have our common is s squared. S squared divided by s equals s times 1, that is s, plus s squared divided by s squared plus 5 times 5, that is 5. Okay, so that is s plus 5 over s squared. Now we have another example. Let's say number 6, the Laplace transform of, let's say the Laplace transform of, let's e raised to t plus e raised to negative 2t square. Okay, so we will do the square. Okay, we have here, we'll just adjust my screen. So of course we have to square first our equation, that is the Laplace transform of squaring this one, that is e to the t times e to the t, that is e raised to 2t, and then multiply 2 times e to the t times e negative 2t, that is plus e raised to negative t. You have 2 e raised to negative 2 times e to the t equals 2et times e raised to negative 2t. So you have to add the exponent, that is negative t. So you have here negative t, and then plus e to the negative 2t times e to the negative 2t, that is e raised to negative 4t. Okay, so when we take the Laplace transform for e raised to 2t, that is equivalent to e raised to 2t. So we look at our table, e raised to 80, that is 1 over s minus a. 1 over s minus a. So 1 over s minus our a here is 2. Okay, so going back, let us check. 1 over s minus a. We have here our a. Okay, so s minus 2 plus, of course, you have here a number 2, so that is 2. And then e raised to negative t, that is similar to this one. We have here 1 over 2 times 1 all over s minus, this is negative 1, so negative times negative, that is positive 1. And then that is plus e raised to negative 40, so 1 over s minus negative 4, that is positive 4. So we have our final answer, 1 over s minus 2. Sorry, I have to write it again. You have s minus 2 plus 2 over s plus 1, and then plus 1 over s plus 4. So this will be our final answer. We can combine all our denominators. Okay, and then let's say another example. Example 7. We have the Laplace transform of 5t cubed 5t cubed minus sine 2t cosine of 2t. Now, when we take the Laplace transform, of course, for this 5t cubed, we will write it as 5 times the Laplace transform of t cubed minus the Laplace transform of sine 2t cosine 2t. Okay, the Laplace transform of, this is a half angle identity, which is equivalent to 1/2 sine of, if this is 2t times 2, that is 4t. That is our half angle for identity, trigonometric identity. This is the equivalent of sine 2t cosine 2t. So that this part is equivalent to 1/2 sine, 1/2 times the Laplace transform of sine 4t. So I will transfer this one. Okay. So rewriting again, we have here 5 times the Laplace transform of t cubed minus 1/2 times the Laplace transform of sine 4t. If we look at our table, this is t cubed, so we look at our table, t cubed. We have here t to the n, that is n factorial over s n plus 1. N factorial over s n plus 1. So t to the n, that is n factorial over s n plus 1. So we will make use of this formula. We have our n here is 3. So we have here 3 factorial divided by s 3 plus 1. That is for the Laplace transform of t cubed minus 1/2. And then the Laplace transform of sine 4t, that is sine at. So we have already solved this one a while ago. Sine of at. So we have here sine of at, that is a over s squared plus s squared plus a squared. Okay, a squared plus So we have here a over s squared plus a squared. So that Laplace transform of sine 40, we will make use of this one, which is equivalent to 4 over our s squared. And then a squared, that is 4 times 4, that is 16, plus 4 times 4, that is 16. Okay, so this is now equivalent to 3 factorial, that is 3 times 2 times 1. So 3 times 2, 6 times 1, 6 times 5, that is 30 over s to the fourth. Minus this 4 is divisible by 2. 4 divided by 2, that is 2. So that is equivalent to 2 over s squared plus 16. So actually you can combine this one if you want to combine as our final answer. Okay, so this is just an introduction to Laplace transform. This will be our final answer for the Laplace transform of this function. Again, this is just an introduction to our discussion of Laplace transform.